In this presentation, we're going to look at the diamonds dataset. So I have a little task here that you might see at the bottom of the screen there. Essentially, let's just get a couple of the preliminaries out of the way. Import OS, so I'm going to use the OS module just to sort of check that. Essentially, all I'm going to really do with that is actually just check I have the right working directory. What is going to happen here is I'm going to read in a CSV file, and it's just handy to know where you're putting things, so that where things can be found. Probably not going to use NumPy here actually. So, but it's handy to have it in any just in case in general as a sort of template for your notebooks. So the task. How many cases are there in the diamond dataset? And create a two-way frequency table for cut and color. And the dataset is there. Dataset at www.bit.ly/PyDataWorkshop, capital P, capital D, capital W. Okay, so what we're going to do here first off is import pandas, and I'm going to call that PD. So import pandas as PD. And the first thing we're going to do is read in our diamonds dataset. So the diamonds dataset is in a file called a CSV file, diamonds.csv, and I have that saved to my working directory, so I don't have to go through any of the path stuff. So I sort of deliberately saved it at the file that was mentioned up here, so that Python would be get OS get current working directory, this thing up here. So that I saved it in there, so it'll be found very easily. Without any bother. PD for pandas. The command is read underscore CSV, and I'm just going for a very simple option there. So PD read CSV pandas, or sorry, diamonds.csv, and I'm going to save that as a data frame. This is now a data frame called diamonds. Okay. So what I could do here is actually have a quick look at the diamonds data set. So let's pick out the command there is diamonds. So what I type in there is diamonds.head. It's an attribute of diamonds. It just prints out the first specified number of cases. Here I'm just going to go for top 5 cases. Okay. And there we have it there. It's the first 5 cases. This is the pandas index, this first column here, 0, 1, 2, 3, 4, 5. But you might notice here that the output of the CSV, or they have an unnamed column here. That is probably the index that was produced when this got outputted from a different program. Okay, so caret, which seems to be some sort of numeric variable, we're going to not look at that in this case. Cut, color, and clarity. Okay, we got a couple of new categorical variables there. Cut, color, and clarity. And we have a couple other ones there again. Depth, table, price, X, Y, and Z. There are a lot of some numeric variables there. I'm not particularly interested in right now, so I'm actually particularly interested in cut and color. And that's all I'm going to sort of concentrate on. So let's say we have ideal, premium, good, this premium. There's a couple of different types there of cut. So those are the sort of levels, to use the phrase, of this categorical variable cut. We also have color here, and there's a couple of colors, E, I, J. That's for the first few there. If we want to sort of print out the top 10 cases, we might see if we get a few more. So very good. There's a H color there as well. Fair E. That's case A8, which is the 9th case, and so on. So we're going to break down, for example, how many cases are ideal cut and color E, and how many are premium cut and color E, and so on. How many altogether? How many cases are there altogether, though? That is the thing. Okay, so what we might do here is, first off, what we could do here is actually use the tail command. This is sort of a bit of a cheat. So this produces the last 10 cases. I'll change it to last 5 cases. Okay, the last 5 cases of diamonds, and it'll print out the index of the last 5 cases as well. We have 53939. That means there's 53,940 as corroborated by the index from that came in on the CSV file. I'll actually show you in a different presentation how to get rid of that if you want, or how to rename it. So that there's 53,000, big data set. It's not huge, but it's big enough. Um, but the normal way to find out how many dimensions we have, or what are the dimensions, would be shape. So diamonds.shape, it's the shape attribute. That corroborates our suspicion that there are 53,940 cases. There's also has 11 variables here, but that might include this case variable, that's sort of the unnamed case number variable. So it's probably really 10 variables. But anyway, we were looking at the number of cases. It's 53,940. Okay. Now, what I could do there is I want to just double check something here. So I'm going to use the describe command here. I'm just seeing, is there any missing values in any of the columns? Okay. So what I'm going to do here quickly is I'm going to see, is this number here, the count, the number of valid cases, is it 53,940 for each of the 11 variables? Well, so far so good there. Go through. Yeah, looks good. Yeah, so essentially that there's no missing values in this data set at all, which is good. It means actually I can pick one of the variables and just sort of work from that rather than having to deal with the whole lot. I'm going to use the caret package. I'm just going to show you what I'm going to do later. So that's the scribe, and essentially what I'm looking for there is the count values. There's no valid case, the full number of valid cases. The data set has no missing values in it. So for example, there's no missing values in depth or something like that. That might change things. Okay, so I'm going to pick a variable that has a full, it's the full, that has no missing values. Now, as it happens in this case, they all have no missing values, but I still need to pick one. So I'm going to pick caret. It's got no missing values in it, so I'll be able to use that to sort of build my contingency table on my two-way frequency table. Okay, because it's got no missing values. Now, what I'm going to do here is impose a grouping structure. So I'm going to sort of impose a grouping structure by cut and color. Okay, so suppose I was just going to sort of diamonds by cut. All I have to do here is I'm going to just comment that last bit out. Is just do something like this. That would impose a just specify the variable that I'm going to group the group by. So it's a categorical variable. It's one of the category variables. It's not a numeric variable. And just specify that variable using this group by attribute. And we could run that. That worked fine. Now what I'm going to do here is I'm going to specify multiple grouping variables. What I'm going to do here is I'm going to specify an array. Okay. So just watch out for that. You specify it as an array if there's more than one. Okay. So you use the square brackets as well. Square brackets for the array and the round brackets just because it's a sort of the group by needs an argument. So we're going to call this by cut and color. There we go. And we could get a description of that. Now, what this is going to be absolutely massive output because there's probably 40 categories or something like that, or subcategories between cut and color, and it's going to give us the summary statistics for each subcategory. So each sort of combination of cut and color, it will give us the summary statistics. For example, fair is the first category of cut and D is the first category of color, and there's 163 of those cases, and so on and so on and so on. And for the next category, subcategory, 224. See, this piece of information is the only piece of information I'm looking for. So that's why I'm going to sort of pick on one of the variables from now on. First off, I'm going to put in a little bracket here and just specify. I'm just going to work by caret from now on, and I'm going to leave everything else. I'm just arbitrarily picking it. It's massively cut down on the amount of output I had to look at, but I could do a bit better. Okay, so what I'm going to do here is I'm going to sort of that helps a lot, but really I don't want the mean of each one. Actually, do you know what? If I wanted the mean for each subcategory, okay, of color, now that's going to give me the mean of carat for each category. Not really what I want, okay. So this is the mean carat of carat for fair D, okay. What actually is really useful here is actually I'm going to sort of unstack that. And what I'm going to do is it's going to give me a two-way table for the mean of carat, okay, for each type of cut and each type of color. So we can see how many. So there's about five levels of cut, and I think there's about 7 levels of color. And we have the mean of carat for each of those categories. So, for example, fair D seems to have a very high carat. Also, premium H seems to have a very high carat. Fair H is also quite high, and so on. Whereas ideal D is not so great, really. I'm not sure if that actually, if that's good or bad or indifferent. Actually, is high good or low good? But let's just go back to what we were talking about. This is not what we were supposed to be doing. Okay, we're trying to find out how many is in each category, and we only picked carat as a bit of a, just because it had no missing values. So what we're going to do here is count, and this will give us the number of instances in each one. And there we have it there, 163, fair, cut, D color, and so on. And that's exactly what we're looking for. The other thing was the diversion. It was interesting enough to find out how to do it, though. So what was the useful there? By cut and color, okay, now that variable there was just one that had a full, I only used that because it was full, or no missing values. Count to give us the frequency for each subgroup, and unstack to sort of present it as a little table like that. I could go on, actually, there's more things I can do, but actually what I'm going to do is actually leave it here now, because it's 12 and a half minutes in, so I pretty much said what I wanted to say.